Okay, this is the lecture for Lesson 7. Now the first thing I'd like to talk about is the picture right here, and I wanted to talk about that in relationship to Project 2, because you will be working on Project 2, which we started in Lesson 5 in this lesson, but you will be at the point where you are working on the value in Project 2. Now this is one of my drawings from 2007, and what the description here talks about is that this is a example of graphite shading using cross-hatching technique. The background values were drawn with a 6H, 4H, and 2H pencils. That's how you get all of these very light values back here. You can still get contrast in these very light values. You don't have to have really dark areas like you see down here that are used with the HB, 2B, and 4B pencils. Now, what else is in here is value shading. Where you'll notice in the background where you can see this goes from a dark to light. You'll notice here where it goes from dark to light, left and right on this little object here. There's from dark to light in the background. Back here, here's one dark to light this way. You'll notice in the front here, dark to light. Dark here on the edge of the arm goes to light, and then it's dark again here. All of these are implied lines, and all they are value contrasts. Now this is a realistic drawing, but again, what you're doing in Project 2 from Lesson 5, you'll be in Part 4 today. And these are some examples of the student work using that same technique that you're learning how to do, which is when you use very good pencil control and you try really hard to maintain an implied line on the edges, you can get some really interesting and pleasing looking designs, which in the future with practice, these things can be done like this. Now this piece here is actually 30 by 40 inches, which is about 2.5 times larger than your large 18 by 24 drawing paper. But this was done on the exact same paper that you work with when you get the 100% rag paper for your projects. So you notice this has values go from dark to light. Some of them are just dark all the way across, but they have contrasting values in here. So that's what you're going to be trying to achieve today when you're working on the final Part 4 of Project 2. Okay, the next thing that we're going to be working on is the vocabulary today. So I'm going to move this out of the way, put it right here. Now, the first vocabulary is a concave line. Now, concave line is a line that is lower in the middle and higher on the edges. A convex line is a line that goes just the opposite. Now, one of the things that we describe here is the term of whether something is a stable line. In other words, if you were to imagine this concave line resting on a surface like this, you could almost imagine it being like a ball. And a ball is not a stable, does not have a stable position to it. A ball can roll very easily in one direction or another. Now if you were to call this, let's say this one, which is the convex line, would be like a bowl. So if you turn a bowl upside down, it's very stable. It's wider on the bottom than it is on the top. So that's considered a stable image or a stable symbol. The next vocabulary word we had was a diagonal line. If we can start with a horizontal line and say that a horizontal line is very stable. It's at rest. And that's also called a landscape format, which we learned about earlier. A vertical line is inherently unstable, but it is not as unstable because, you know, visually, a line like this is considered to have more action or drama to it. This is called the portrait format, which is not at rest. It's to resemble a person standing up, for instance. And most, you know, the way that most non-objective art does rely on those symbolic relationships of lines and images, but you can also use that symbolic relationship when working on realistic things. And which brings up my next point, which is a diagonal line. And you notice the strongest point in here is a diagonal line, which would be very different from a vertical line and would make the composition look very different. You notice how these diagonals on the ends point inward to kind of focus in on the composition. You notice there's no horizontals in this composition, except for the format. Almost all of them have a slight angle in one direction or another. That's because a diagonal line implies direction. It implies that it could either fall down, or it implies most of the time that it's traveling off this way. Now, you may, you know, just say, well, maybe that's a little too over analyzing it, but not really. But these are real basic fundamental design principles when you are organizing and learning to draw a composition, so that everything isn't all straight up and down or horizontal. So that means when you go back to drawing your project from project 2 from lesson 5, that a lot of these relationships have to do with a symbolic feeling about how the piece will actually look to the viewer. Okay, now we have a couple other words. I want to talk about ellipses for a minute, and that's the next word on the vocabulary list. And I mentioned this last lesson lecture, that I said, well, we mostly concentrated on these two items here. And now we're going to talk about this one. Part C, this is from lesson 6 now, but the vocabulary word, we didn't use much of the vocabulary of this in lesson 6, but we will in 7 here. Okay, we learned a long time ago in lesson 1 that a circle is more accurately drawn if it's drawn inside of a square, which means it has 4 equal sides. So an ellipse is, and you could also call it an oval. Some people call it an oval, but artists call it an ellipse. That's spelled with 2 L's and an IPSE. So any rectangular shape, you can draw an ellipse in there accurately, and I will do that right now. And an ellipse is made up of a concave and convex lines. Now, you could freehand an ellipse. That's not very good, is it? Now you notice that I'm right-handed. It's easy to make a smooth curve to the left, but not as much to the right. Maybe if I start up here and do another one, and maybe it's a little better. But you see, there's the analysis, or let's say the anatomy of this, is that if you start with a rectangular shape, and a rectangular shape is any shape that is longer than it is high or higher than it is wide and has 4 right-angled corners. Now, if you were to divide this in half, just like you did when we did a circle, and a lot of times in measuring and drawing shapes, you always do that anyway. Now, an ellipse, you can start anywhere you want, but what you're trying to do here is only touch the rectangle at that point. That's not that easy to do. So it only touches at that point. And it doesn't matter where I start and where I stop here if I want to back up. So now I have something that looks more symmetrical. a true ellipse is symmetrical. In other words, if I was to divide this in half along these marks that I used, both halves should be equal. Also, that means this half and this half. And if I divided it this way, those should appear even and equal. The other thing about drawing an ellipse inside of a rectangular shape is that, as we learned in Lesson 1, the negative shapes here should appear to be equal. Now, if I was to draw a rectangle around one of these that I just freehanded, you'll be able to more obviously see the difference. One of the things that I noticed right away, you see how this negative shape over here is a lot longer than this one. This one's very short. That means that this ellipse did not touch in the middle. It kind of touched the border way down here and then went straight along here and came back up. So whenever you draw a geometric shape around what you want to draw and using the negative shapes, it's much easier for you to draw something more accurate. So this is an ellipse. Now, one of the things we're learning in Lesson 7, we're beginning to look at objects. And one of the objects, again, being a rectangular shape, not a rectangular plane, okay? So a rectangular shape is now the illusion of 3 dimensions. So let's talk first about the parallelogram. A lot of these things are geometrical terms which rely on 2 principles. One is parallel lines, which these 2 lines are parallel, and the other one is where the sum of certain kinds of angles will make another angle. But this isn't geometry, so all we're talking about here is parallel lines, and this is the term, this is a parallelogram. Now, in most simple perspective, which you're going to learn in about 2 or 3 more lessons, has to do with parallel lines and parallelograms. Now, that's a parallelogram. This is a parallelogram also, if I was to do it this way. It doesn't matter which way I do it. Okay? The idea is that the sides are equal, opposite sides are equal, which means that the opposite angles are equal angles, whatever degrees those are, which is based on the opening here. This could be 45. A parallelogram doesn't have a stated angle, it's just that these match. Okay, so why are we talking about this? Well, in a illusion of a shape, this, if I was to complete this shape, and let's say I make a square here, you see what's happening now? So I made a square and a parallelogram. Now if I take this parallelogram and put it over here, then I end up with this. So that's why I'm discussing parallelograms here. Now, the other shape, we've talked about rectangles, parallelograms, and a trapezoid. And so why do I need a trapezoid? What is a trapezoid? Well, it has 2 parallel lines, which is the top and the bottom. The other 2 lines, these angles, the sum of these 2 angles comes up to a specific degrees. But the idea is that they are similar, or something you've already learned about, which is symmetrical. Okay? Now, is a trapezoid always symmetrical? Well, if it's not symmetrical, what does it look like? Or what is it called? I would say, let's try this. Now, is that a trapezoid? Well, it's more of a quadrilateral. It could be any angular thing. You had 2 sides parallel, and that's it. Okay, these other 2 can come in any angle you want. You see, why do we want to talk about these like this? Because as we approach looking at visual objects, in order to have a dialogue about it, you need to know that if I say that is more of a trapezoid or more of a symmetrical shape, it's because in one-point perspective, it would probably look like this. If you were standing directly in front of this shape, it would look like this in perspective. Now, if you wanted to move a little more to the right, over here, you might see this as the top shape. This top shape is also called a receding plane, this thing. It's a illusion. It's really a quadrilateral shape. This is really a trapezoid. This is really a parallelogram. And students get confused because if you don't understand, what you're talking about here, you can make any old shape. And then the illusion doesn't work. It's destroyed because your eye is expecting certain symbols to do certain things. The way we talked about these do certain things to your eye and your expectation of your brain about what you're drawing. Once you understand these things and you work with them consciously, then it's easier for you to do more complicated drawings like this. Okay, so we covered all of the vocabulary. Now we're going to talk about this here. So this is basically a grid system. Now, a grid system used in computers, you would say, well, you have an X, or in math, you have an X axis, horizontal, and a Y, which is vertical. If you keep at first into a simple, totally vertical or horizontal measuring system, it's easier for you when you're first starting. Now, all this is a verbal description of what I'm talking to you about right now. And then we're going to apply this to today's exercises that are in the Lesson 7. Now, all this is showing you this is a blow-up of this area right here. And all this is showing you is that this rectilinear shape, solid, is in front of this one and it overlaps it this much. Now, a student could draw that, and maybe if this one was this one, for instance, and a student was looking at this other one, they may draw it over here, for instance.